everyone, my name is Paige Bailey. I lead our developer relations team at Google DeepMind, and today we're going to be doing mostly demos. So I do have a few slides at the very beginning talking about some of the things that we've been building and getting out into the world at Google. But for the most part, this is all about the things that you can build today with AI systems and then what's coming up in the next 6 to 12 months. Because I am of the camp that believes that by the end of the year, we will have models that can write code better than any human who has ever existed. And if that's the case, then it really opens up a lot of possibilities into how businesses are going to be transformed and then also society at large might be transformed. So certainly generative AI is transforming everything that we do at Google, how we build our products, how we deploy them, all of the different features that we incorporate into them. And we've been thinking about AI for a very long time. I started using some of our machine learning frameworks that were open sourced whenever they first came out. Around 2015, and then also JAX when it was released in 2018. Some of the models from our colleagues over at DeepMind, like AlphaGo and AlphaStar for playing StarCraft and playing the Go game, automating it, as well as AlphaFold, which just recently won a Nobel Prize in chemistry for John Jumper and also DeepMind's founder, Demis Hassabis, on through Palm 2, and our latest model family, which is called Gemini. And Gemini 2.5 Pro is pretty exciting. How many folks have heard of this model in the audience? Several hands, amazing. So Gemini 2.5 Pro is important for kind of a few reasons, right? It's multimodal, which means that it understands video, images, audio, text, code, all of the above all at once. But even more importantly, it supports multimodal outputs. And today, the multimodal outputs are text, code, images. So this model can natively output images. It can edit images, and it can also have an output of audio. So you can have natural conversations with the model the same as you would with a human. And a variety of accents and using things like tools and code execution and grounding with Google Search, which we'll see in a second. This is cool for a number of ways. And when I first saw it, I was just kind of blown away. I don't know about y'all, but I started doing machine learning back in like 2009, so it was, like back before it was cool. And back then, the world looked very different as well. Most people were trying to either hand roll their own algorithms, or they were, scikit-learn was very nascent, and so you were trying to incorporate some of the tooling from there. But today, the world has dramatically shifted, right? Like the things that you can do with these models are kind of more staggering than I could have ever imagined. And when we were first building the Palm 2 model and our first Gemma models, and even our first Gemini model, my expectation was always that you would have kind of like this dense model that could output text and output code, and then you could kind of stack on a diffusion model on top to get the more like image and audio outputs. But that's no longer the case today. It's all unified. One model to kind of rule them all, I suppose. But it's really, really exciting to see. What this means is that you can give the model things like an image of a car and have it output minute changes to that image. Or you could have it generate images from scratch, ask for a storybook with images and text interleaved. And it's not just about the digital world. We've also been putting Gemini on robots. So these are all videos of robots that you could see if you go to Google's campuses in Mountain View. We've also been partnering with folks like Boston Dynamics and Enchanted Tools to bring our models onto these robotics systems, either through API calls or just having kind of our open models, our Gemma model family fine-tuned for robotics use cases. This is rad in the sense that you can have this video input feed, an audio input feed, and then you can use Gemini to generate code to operate the robot. And what this means is you can say something like, please go make me a salad. The robot is able to kind of use these models to reason, to identify all of the steps that it would need to do, and then to write its own code to navigate it. So like self-navigating, self-operating robots, which is amazing. And again, like these are things that exist today. And so if you speed ahead like 6 months, 12 months, much less 5 years, like the world is going to look very different. We also have recently, released AlphaFold 3, specifically geared around AI as applied to protein folding, which can help with things like drug discovery and really kind of changing the way that humans are doing science. We'll talk a little bit about how we're using agents in the scientific world as well pretty soon. Alpha code for competitive level programming, GraphCast for weather prediction, plasma control for fusion science, and then a whole host of other things are being done in Google DeepMind to help with Google's businesses, so things like Waymo, as well as our TPU chip design, and Willow, our quantum chip design, but also the rest of the world. So getting the APIs and the models out into the hands of folks so that everyone can benefit from the things that we've learned about applying AI to science and scientific research. So our models come in a broad spectrum of sizes. We have Pro, which is our largest model. It's the one that we were just talking about. Flash and Flash Lite, which are smaller, a little bit more lightweight, a little bit more kind of lower priced. They're the ones that I see most commonly used in production. Flash Lite is around 7.5 cents per million tokens of input, which means that you could record everything that you do on your laptop 24 hours a day, 365 days a year, and analyze it each week for less than the price of a cup of like fancy coffee. So really, really cost effective. And then also Gemini Nano, which is small enough to fit on a Pixel device. So we put it on Pixel devices. We've also embedded it within the Chrome browser, which means that you can use the model locally without sending your data over the wire to some other system. And it's great for things like translation, summarization, and a couple of other things that we'll see. So like kind of like the three bears, like big, medium, small, and useful for a broad spectrum of tasks. We also support long context windows, which I don't think we often do a great job of explaining why this is useful, but it means that you can give the model a lot of information right at inference time. So all of the emails that you've sent in the last year, all of the text messages that you could send in a lifetime, lots and lots of textbooks from all of your college courses, the entire first season of Silicon Valley, the TV show, without commercials. You can just give it to the model, ask it to analyze it, and it's kind of off to the races. And the models have been doing pretty well on leaderboards. This is from the LM Arena. Even more excitingly, they have this beautiful kind of Pareto price curve of you can do a lot with the models, but they're relatively inexpensive for those tasks. And we also have an open model family called Gemma 3, which comes in a broad spectrum of sizes, so 1B, 4B, and a couple of others, as well as a 27 billion parameter version, which is around on par with DeepSeek, but requires one H100 to run as opposed to 32. So much more lightweight, more cost effective, et cetera. So that's a lot of talking, and I do not like talking as much as I like showing. So with that, I'm going to zoom over to AI Studio, and we're going to take a look at some of the things that these models can do, just in case folks haven't already seen them. So this is AI Studio, which is kind of the best place that you can go to get access to Gemini and DeepMind's models as soon as they come out. You can do a broad spectrum of things, so you can click the plus sign, upload files, record audio, camera, add a link to a YouTube video, or you can just use sample media. You can also link to your drive, and you can start asking questions. So I'm going to select the dinosaur video just because I really like dinosaurs. And I'm going to say something like, please create a table of all of the dinosaurs in this video with timestamps. Also add a fun fact about each dinosaur, and then hit run. And you can see that this is around 88,000 tokens, so it's a 5-minute long video. That makes sense. I'm using our Gemini 2.5 Pro preview model, which you can see here off to the right. You could also use a different model if you would prefer, so something like Flash Lite or one of the smaller versions. But you can also see this box that pops up to the top that exposes all of the thinking traces for the Gemini model. So this model is kind of building a goal or understanding the goal, thinking of a strategy for accomplishing the task, and it's kind of like having a lens into the process of the model for accomplishing whatever you would like to see. So after that thinking box, you see the table with the dinosaur name, the timestamp, and the fun fact, which means that it was able to take in the video, analyze it just using the frames, and in a relatively short amount of time, give you back all of that information and insights. So as you're thinking about, like, all right, well, I want to know for my security camera footage, identify anything strange, or for this college football game, identify all of the times that my logo appeared, and then price out how much it might cost if I want to get like 50 additional seconds of showtime for that logo. All of this is possible just through asking a natural language command of the model. And if you hit the Get Code button off to the top, so this little bracket right here, you can start seeing the code that you would need to write in order to replicate the experiment you just did. It also works for things like data analysis. So I'm going to go ahead and turn on something called code execution, and I'm going to ask, please create a cluster plot for the iris data set from scikit-learn. Hopefully folks know about the iris data set. Also include basic statistics about the data set, and then hit run. Behind the scenes, you can see the thinking box kind of pop up. It builds a plan, something that it would need to do in order to accomplish this task. And then Gemini goes ahead, writes code, runs it, and then recursively edits it if it needs to in order to accomplish the task. So what you do when you turn on code execution is you give Gemini the ability to write code, run it, and then recursively fix it to accomplish the task. So you can see here, pretty lengthy code snippet. If you scroll down, you can see the basic stats about the data set itself. So it's just a lot of information about the iris data set. You can see it encountered an error. And so Gemini thinks again, like, why would this error be occurring? It realizes that it needs to change the code, so it does. Reproduces, and then creates the plot for you with the different data sets. You can also upload CSVs. You can point to data that might be in tables, but all of this is just possible by turning on code execution as an option. And kind of giving the model the reasoning ability to be able to write code and then recursively fix it over time. So both of those things are possible. We've also implemented something called Gemini Multimodal Live, and hopefully y'all will be able to hear this. This gives Gemini the ability to see, to hear, and to interact with everything that y'all see and hear. So I'm going to turn on grounding with Google search, which gives it access to up-to-date information. But what you can do is you can start asking really interesting questions. So I'm going to show it a Chrome tab that is the Gemma 3 latest model release. Or I will try, let's see. It might be that it doesn't want me to do it when I have the connection on, but we'll try again in a couple of seconds just in case. You can interact with a lot of models in AI.dev, which is this AI Studio link that we see here. And you can also do things with Gemini and our Gemini app, like with Canvas, where you can say, please create a marketplace app to sell Pokemon cards. Make sure to use emoji. And what happens is kind of behind the scenes, Gemini begins thinking again, so you can inspect all of the traces that should be created, all of the different prices. Gemini starts writing code, so you can see it happening in real time. And then you can also see a preview after the code gets written of the app itself, and the ability for you to go and deploy it. Yeah, so this is kind of a a very simplistic web app for selling Pokemon cards. It does indeed have emoji, so you can see Snorlax, Jigglypuff, Lapras, Magikarp, Eevee. I don't know who selected the prices for all of the Pokemon, but it's just an app that you can kind of copy and paste, and you're off to the races yourself. For folks who prefer VS Code style experiments, though, or VS Code interactions for writing code, Gemini works within Copilot. It works within a kind of Cursor, Windsurf. You can use it with RuCode, with Klein, with a broad other variety of IDEs and developer tools. But you can do exactly what I was just describing, as well as get kind of additional insights into your code base. So as an example, this is something that I was trying out with Copilot just over the weekend. I mentioned that we've recently updated our generative AI library to a new one. And so I asked it to help make modifications across the code base to support those changes. So I was able to identify which files needed to be adapted, as well as to add a descriptive error on the README. We're also applying AI to the pull request process. So not just, as a developer, I don't know how many folks in the audience are developers, but usually on a good week, you might spend 5 to 10% of your time actively writing code. The rest of the time is just a little bit of the kind of bureaucracy required to make code actually happen and to actually exist in the world. And as a result, what we've been doing is incorporating AI into the pull request process. So each time we get a pull request on GitHub, Gemini is triggered as an action. It gives a summary of changes, a change log, and then also gives insight into merge readiness, as well as indicating if there's a review required. For some of the models, it also gives you the ability to, it also recommends code changes for this as well. But as Chip mentioned, the really magical part is being able to integrate it into systems. And so I'm going to show you today our Colab data science agent, which is something that you might be interested in using for your work. I'm going to go ahead and add, let me try adding a CSV file. Yep. Cool. So just added a CSV, and then I'm going to say, please do exploratory statistics on this data set and help me build a predictive model for housing prices. So again, Gemini kind of thinks for a little bit. It opens up, this is just a California housing data set. It's a CSV that I've asked Gemini to help with. It thinks about data loading, data exploration, data cleaning. Also, please don't judge me by the number of untitled notebooks that I have in Colab. It is one of my favorite tools and products, but you can see the kind of execution starts for the plan. And behind the scenes, the agent writes the code cells, runs them. So you can see here that it's pulling in the data. It starts doing a little bit more of the exploration. So this is just the APIs that we saw in AI Studio. This is just them integrated into the Colab user experience. So you get these really lovely text cells with some reasoning associated. You get it writing code, which can also do kind of basic data exploration for some of the features. So you can see here some of the plots that it's created off to the side, as well as exploratory stats about the data set itself. And then also you can see kind of next steps recommended as well. If it hits an error, it goes about fixing it for you. It identifies kind of data cleaning steps that need to occur in order to solve the task 2, and goes through the training process. So lots of really exciting things happening in the world of AI, especially AI as applied to data science, as applied to machine learning, as applied to software engineering. There's never been an easier time to build things, even like if you're a web application engineer, if you're a data scientist who wants to be able to analyze some of the things that you're doing for your work. I encourage you to test out all of it. If you have an idea, getting it out into the world has never been, there's never been a clearer path to making that happen. And tomorrow we're going to give a workshop, so if you want to know how to use some of these tools, how to incorporate them into your jobs, happy to talk through that a little bit more. Cool, thank you.